As of now, we have seen the what and why of analysis, in which we covered like how the expected data should look like, what are the features we can think of, and what is the systems approach we can follow, what are the processes and what are the levers of the system. And we also saw that what are the KPIs and engineered features that would make sense in this analysis. Now, let's dive into how do we actually do this. In this video, we'll talk about the exact step-by-step system I use to go from a raw data to real business impact, whether it's customer churn, logistic delay, or revenue forecast. We'll start off by looking at the data, and the first two step of any analysis would be importing pandas and reading the file. And you see that we have 26 columns here and close to 1 like 44K records. And if I look at the column name and description, which we have already discussed, there were three items pending, which is cutoff factor, and cutoff timestamp. And so what I'll do is I'll clear all the outputs and I'll rerun all the cells again. So let's discuss about these three is cutoff factor, and cutoff timestamp, and how they are looking like. I'm using Data Wrangler package, which you can get it. You can install it from the um, package extensions. You just have to search for Data Wrangler and install it. Very handy. I use it all the time. Okay. So navigating to is cutoff. So you see, we have 82% of the data which has the value true in it, and close to 18% of the data which has false in it. And there's something called as cutoff factor and cutoff timestamp. So as of now, looking at just these values, you can see there is a direct correlation with actual distance, which is distance and kilometer. S- Uh, for example, in this case, 18 is related to this, 27 is related to this, 36 is related to this. So roughly, we can think that cutoff factor is like the approx distance in kilometers. Cutoff timestamp. This is an independent feature. I think, depending on the business definition, they must have decided a unique cutoff for each of these trips, and through this, they would be deciding the SLA and analyzing if the delivery was done as per the expectation or not. And the last thing was is cutoff factor. How this is getting decided. Um, So directly jump to there are a few more univariate analysis over here, but let me directly jump to is cutoff analysis. So if you'll take out a summary statistics, this is how it would look like that like percentage of we which we already saw, like percent trip having false and true distribution is 87 and 13, and route type is like it is skewed to karting. Like a lot of route type in this type of wherever we see cutoff is equal to false is related to karting, thereby implying that these could be the last minute order which was not fulfilled before, and they are trying to like accommodate in the current run. Okay, true, we already know. Let's look at false. So the higher delay ratio, larger idle time, and slack time. Common during high load hours. Some trips cover mid route, and it kind of shows up the catch up behavior. So basically, cutoff is the process discipline marker. It's not a flag. Strongly linked to operational punctuality and SLA. Non Non-compliant hub indicate processes or staffing bottleneck and acts as an early signal for a downstream delay. So it reflects the discipline and congestion. Missing cutoff is equal to not equal to failure, which means the recovery possible or post dispatch. And combining with the batch density and cutoff punctuality in operational slack, it sets an early warning feature. So basically, from all this, we can draw this conclusion that there are few orders which could not have been fulfilled before, and those are marked with cutoff is equal to false, and they are trying to inject these deliveries into the current run to make the delivery possible. Okay. All right. Let's now do the univariate analysis. Here again, no need of doing that. We already know from this data wrangler that we have these many rows and these many columns. So it's a little bit of an overkill to look at the shape. But info would give us a lot of univariate information. For example, we would try to find out which all column or which all features have some null values in it, which we might have to impute it because doing a predictive analysis, any type of predictive analysis, uh, it cannot work on a null data. So we will have to impute it or remove all the null values. So in this feature, we see a little bit of null. Here also we see a little bit of null and unnamed 24 column. Anyways, this has a lot of null in it, and the rule of thumb is that if a column has more than 80% of the data as null, we generally drop those columns and not consider in our analysis. Okay. And another observation over here is even the column which is supposed to be in a datetime format, right? They are of object type, and to do any kind of uh, temporal analysis, time of the day difference, right, we need this into with the correct format. So this is how we are managing it by converting the trip time, right, od start time, od end time, cutoff time into the proper formatting, and then proceeding with it. And describe, I'm in love with this function describe. And just by including all, right, I can basically see the descriptive statistics of all the data type, including these are all the categorical data type. Here also we can see the descriptive statistics as well as the numerical data type. We can also see the descriptive statistics. So let's see if this has any surprises for us or not. um Starting with the creation time, the minimum is of September 12th and the maximum is of September 26th. So roughly we are looking at 1 month of data. This is the inference we can draw. Right. And let's look at our identifier, which is going to be the backbone of our story. So root schedule UID and trip UID. These are the two identifiers which is like giving us the story. And in these, let's look at how many unique values we have. So in the trip UID, we have 10,000, close to 11K unique trips, right? Whereas root, you will see we have only um, close to 14, I mean, 1,400 unique schedule, which means the road or the route the full truck is taking or the carting is taking is predefined, and they usually take those routes only. Whereas the trips are unique, and I mean, the number of trips are unique. Basically, this analysis, we would be able to look at route congestion, and if that route is best for full truckload or half truckload or carting. Whereas trip UID, we can use this trip UID to find out that uh, which destination or which center is acting as a bottleneck for the trip and so forth. Center name, center, and destination name. These are the two identifier for the source and center, right? Start time and end time we already discussed, and it is again consistent with the creation time, roughly that same 1 month window. Um, we already have discussed in our previous video what is the meaning of all these variables. Here we are trying to, from this univariate analysis, we are trying to see if we are getting insights from it or not. So this is as per the expectation. Start scan to end scan is in minutes. How many minutes it is taking for a delivery to happen? So you would see that on an average, which is the mean, and uh, we'll also take a look at the median, which is a 50% value, right? Let's take a look at mean first, and for this, approximately 950 minutes is taking for a delivery to happen, whereas median stands at 453. So obviously there would be a lot of outlier in the data, hence the um, mean is slightly towards the higher side. But median we can conclude that okay, 450 minutes on roughly each trip is taking around this much of time to deliver, like from the start to end. Okay. Both RM time, factor time, segment factor, all this is um, giving us the same information from a different point of view. Segment will tell us from a more generic and segment point of view, whereas like these are actual trip related information. So generally in our analysis, what we'll try to do is we'll try to compare our trip level analysis with our segment level analysis. Okay. So in, like, although this describe feature is quite helpful, and it gives us the snapshot of the count, uniqueness, and frequency, but still we would like to look at what are the top 10 values for each categorical columns, right? uh, Root schedule id would not make sense for us to like go through what are top 10 value, because we cannot decipher what is the meaning of this. But the name, if we are able to see the name of the root, we would get more information from it. Yeah. This is these are the top 10 route schedule ID. So the top 10 trip UID, top 10 centers, and along with the name. So I think Gurgaon or Gurugram in north is serving as the major center for any of these delivery. I think how this should be functioning is that they have the main center at Gurgaon, and from Gurgaon they are taking it to the other smaller centers, and then that's how the order is getting fulfilled. So from Gurgaon, it could be arriving to like Delhi airport hub, and no, I think it goes the other way around. From Delhi and other places, it would be arriving to Gurgaon, and from Gurgaon, maybe the individual delivery would be taking place. By destination name, again, okay, you would see the same names getting repeated over here as well. The reason for that is hidden in our data. Let's again try to look at our data, and what I'll do is I'll select the the trip which has the most number of trips in it, right? It has 101 trip in it, and I'll select this and I'll try to filter on this trip, and there is a unique thing that will emerge from this activity. Let me just show you. Yeah. So I want your attention to be focused on the source and the destination. So from the source, you would see that it is reaching to Muzaffarnagar, and then Muzaffarpur. I'm sorry. Then the Muzaffarpur becomes the next source. So basically, from Gurgaon it goes to Muzaffarpur. Then the Muzaffarpur becomes the source, and from Muzaffarpur it goes to Purnia, right? Then Purnia becomes a source. Then again it goes to Bilaspur. This is how the order is getting fulfilled. So doing a analysis individually on source or on center or on destination would give us the same exact information or findings or insights. Okay. Okay, so this was all about the univariate analysis. There are few features which we did not touch upon, but the main features were the source centers, which are the top 10 source center, top 10 destination center, as we discussed, giving us the same information. Cutoff we already saw, and these features we are anyways going to drop. So now let's take a look at bivariate analysis. And the most common way of doing that is doing a pair plot or doing a correlation heat map. So let's have a look at them one by one. Actually, like if I was doing for my own analysis, I would just select either one of them, because ultimately from both we are getting the same kind of information, but it's better to see how the data is represented in both of them. So we have the pair plot for all the variable, and let me just pop it out and open expand the image, right? So how to interpret a pair plot? First thing first, that in diagonally, uh, since the feature is plotting against itself or being plotted against itself, you will notice a frequency distribution in form of histogram diagonally along the principal diagonal, and ignore all the features where you see the distribution is random, it is not following any pattern. And in xy plane, right, we would be only interested in looking at a linear pattern like this. Very rarely, I have never come across a sinusoidal or any other kind of geometric pattern, but most common is the linear pattern, which you kind of see over here. So, which if we have a linear pattern between two factors or between two variables, they are somehow related to each other. Let's take a look at few. So actual distance to destination. It is showing a perfect correlation with cutoff factor, and we just discussed that cutoff factor is nothing but the distance in kilometers. So hence, naturally, they would be correlated. OSRM time is very correlated with, again, the factor cutoff factor, because the OSRN time is again proportional to the distance. In the previous video, we know that OSRN time is the rough estimate from the Google Maps. So it will give us approximately how much time it is going to take between the distance from source to destination. So naturally, it is related to the cutoff factor. Um, let's move to a different variable. Okay. Cutoff factor, actual time to distance. Okay, we have discussed about this. Was Saran time, was Saran distance. Okay. To visualize the same thing, we can also have a look at the correlation heat map. I find it much more easily uh, easy to understand because of the color coding over here. So whichever I would say which has a value greater than zero point 0.6, um, we understand that there is a correlation between them, and the and hence it is important to study the nature of relationship. Okay, actual time cutoff factor we just discussed. It's zero point 0.9, and along the principal diagonal, obviously it is 100% related to itself, right? So hence it will be 1. Uh, and surprising thing is, yeah, uh, actual time is related to actual distance to destination. All this zero point 0.9 it features are somewhat a certain distance to a certain time. Okay. So obviously to cover that distance, it will take a fixed to cover a fixed distance. It will take a fixed amount of time. Hence, it is highly correlated. Let's ignore all this because we already know that they are going to be very much related. Similarly, same pattern we can see segment over certain time to segment over certain distance. Right? Time and distance, all these factors make sense. Uh, Unnamed 24, we are anyways going to remove it. But here, other than what is this? Segment factor is related to segment actual time. Yeah, makes sense. No joke. Factor. I think we have already discussed. Factor is related to segment factor. No surprises there. Okay. And we also discussed what does this is cutoff mean. So now we have covered the univariate analysis. Next, we will cover the business analysis and the feature that we are going to engineer.